Then let's work on this sort colors problem together, and let's go through the problem first. So we're given three colors, which are red, white, and blue, and we use three integers to represent these colors respectively. And we would like to sort the color in the order of red, white, and blue. So there is also another restriction, which is we cannot use sort function, and also there is a follow-up function question, which is to come up with a one-pass algorithm using only constant extra space. To do this problem with the follow-up question, we clearly need to use a quick sort approach, and let's start that. So firstly, I will use three variables, which is P0, P1, and P2, P1 and I. And in this problem, I would like to write P1, P0, I will equal to 0, and I would like to add the elements in I. This one should be 0 to elements before P is P0, and then the second interval is from P0 to the element before I, and in this interval I want all the elements to be 1. And finally, for the interval P1, length of nums, for this interval I want all the elements to be 2, and to satisfy these loop invariants, to satisfy these loop invariants, I will write P0 equal to 0 at first, and then I should also to equal 0 at first, and P1 should equal to length nums. So with these three conditions, these three initializations, we will know that at the beginning of the algorithm, all of the three intervals should be empty, and then we will add the elements into the interval one by one. So while I is less than P1, so while we will set this ending condition to be while I is less than P1, it is because the second interval the second interval n do not include the element nums I, and this interval go up until to nums I minus 1, and this interval starts from nums p. So when I equal to 1 is when I minus 1 is equal to p minus 1, which is that when I is equal to p. So at this time, we will know that we have already found these three intervals, which can be added up to constitute nums, and also these three intervals will not overlap. So the ending condition should be I equal to p. So the while loop should be I is less than P1. Sorry, P1 here. And for this while loop, I will have some if statements inside. So if nums I equal to 0, I will exchange the positions of nums I and nums p0. So nums p0, nums I. So and then I will add 1 to p0, and I will also add 1 to add 1 to I. So through these steps, we will add one element to the first interval, and then we will also add one to I in order to check the element that is next to I. Yeah. So basically that's it. And then we will check if nums I equal to 1. We will do nothing to p0 and p1. And in this case, we will just add 1 to I. And if nums I equal to 2, we will do something to p1 and I. So we will exchange nums I, nums p1, and we will also we will actually -1. We will actually conduct a -1 operation on p1 first, because we know that this interval is already, all the elements in this interval is already equal to 2. So we will need to conduct this minus operation to p1, and then in this case we can exchange nums I and nums py, and we can expand the third interval. But we will not add 1 to I, because we do not know the actual integer of nums p1, and we will need to check whether this integer is equal to 0, 1, or 2. But here we add 1 to I. That is because we already know that nums p0 must be 1 because of the definition of the loop invariance. And that's it, and we will return nums. Okay, so the time complexity will be O(n), because we just iterate through the nums once, and the space complexity will be O1, because we do not use actual space.